This is the homework helper for Chapter 6, Section 1 in the 7th grade textbook entitled Percents. So the top 3 questions here are all going to use the same approach because they each consist of 100 grid boxes, which is a good thing because we're talking about a percent, and a percent is a comparison to the number 100. So all we have to do is find the number of shaded grid boxes and write that as a comparison to 100. So in number 1, obviously the best place to start is to count some grid boxes. The shaded grid boxes. So in this upper left square here, you've got a 3x3 grid pattern, or 9 grid boxes. Down here in this lower right corner, you've got a 2x2 grid pattern, which is 4 grid boxes. And here in the middle, you have a 5x5 grid pattern, which is 25 grid boxes. So if we do some quick adding there, 9 and 4 make 13, plus 25 is 38. So you have 38 covered grid boxes out of 100 total grid boxes. And again, when we compare to 100, because the definition of percent is per 100, the top number is automatically your percentage. So since the top number is 38, this is 38%. All right, let's go ahead and take a look at 4 through 15. In 4 through 15, the directions are the same, so the approach is the same. So what you're about to see me do in 4, 5, and 6, and 7 is what you're also going to do for 8 through 15. You're writing the percent as a fraction in simplest form. So the first thing you want to do is actually convert these into decimals so we can go along the path into converting these into fractions. Remember, the way you convert a percent to a decimal, as you saw in the notes today, was to eliminate the percent sign and then move the decimal twice to the left. When there is no apparent decimal, meaning we don't see one, it's presumed that it's after the last number. And when we look at all of these questions, we don't see any decimals. So after the last digit, whatever's in the ones place, is where the decimal begins. So in number 4, I'm going to get rid of the percent sign, and then I'm going to go twice to the left, 0.16. Number 5, I'm going to get rid of the percent sign and go twice to the left with the decimal, 0.49. In number 6, I'm going to get rid of the percent sign and go twice to the left with the decimal, 0.20. And in number 7, I'm going to get rid of the percent sign and go twice to the left with the decimal, 0.15. Okay, so now what I want to do again, when I'm changing these, the next step would be to go to fraction, is identify the place value of the last digit. And that last digit is going to go in the denominator of my fraction. The numerator of my fraction is going to be what you see there without the decimal point. So each one of these ends in the hundredths place right now. So the denominators are all going to be the same in each one of these questions, 100. The numerators, again, what you see, just forget the decimals. So 16 and 49 and 20 and 15. Now if you're saying, well, why didn't we just take that guy and put it over 100? You're right. Right now it does work to always put them over 100. However, not every single percent is going to work out that way, especially when I start giving you things like, say, 383%. All right, so in that situation, then, you're going to need to know this general approach. And that's why I'm showing you the way that works for everything, as opposed to these percentages that look like paper and quiz and test scores. All right, so now it's just a matter of reducing here. So in number 4, we want to divide out the greatest common factor. And remember, when I'm talking about reducing out the greatest common factor, what I mean is find the greatest common factor of the numerator and the denominator, the top number, and divide it out of both. And once you do that, the result will be that fraction in simplest form. So with 16 over 100, the greatest common factor of 16 and 100 is going to be 4. So I'm going to divide 4 out of each of these guys, and I end up with 4 25ths. And that is my final answer. In number 5, where I've got 49 100ths, well, 49, nothing's coming out of 49 other than 7, as you're well aware. So 7 would have to come out of 100 to make this reduce, 7 doesn't come out of 100. So 49 over 100 is already in simplest form. And number 6, 20 100 is probably one of the easier questions. We know 20 would come out of both 20 and 100. So I'm going to divide 20 out of each of those guys. 20 divided by 20 is 1. 100 divided by 20 is 5, 1/5. And in the last one there, number 7, we've got 45 100ths. So I'm going to chop out the biggest number I can, the greatest common factor of 45 and 100, which is 5. When I take 5 out of 45, I get 9. When I take 5 out of 100, I get 20. 9 20ths. And we'll conclude by looking at the questions at the bottom of the page here, where they're asking us to write the percent as a decimal. Now, changing a percent into a decimal is something we've already done. We did that in questions 4 through 15 as our first step. Again, all you have to do to change a percent to a decimal is eliminate the percent sign and then move the decimal 2 times to the left. So we'll go ahead and take a look at 16 through 19, but you're going to use the same approach then in answering 20 to 27 on your own. In 33%, we eliminate the percentage, so it just says 33, and then I go twice to the left with the decimal, and we have 0.33, final answer. In 17, with 57%, I'm going to eliminate the percent sign, and then take my decimal and go twice to the left, and I end up with 0.57, final answer. In number 18, with 46%, again, I'm going to eliminate the percent sign and then take my decimal and go twice to the left. And so when I do that, I end up with 0.46. Now, if you're saying, where are you seeing these decimals? Remember, I'm not. You will in the next line, but right now I'm not. When we don't see an apparent decimal, meaning there isn't one visible, we assume it's after the last digit. All right, finally with number 19, 6%. You're going to eliminate the percent sign. So now it says 6. And now I'm going to take the decimal and go twice to the left. Now in this one, a little bit different than some of the other questions we've done, we have an empty jump there. We jumped past the 6 and then we made another jump. Because there's nothing in that first hoop, that's going to fill in with a 0. So we have 0.06 here. If you write 0.6, well, let's reverse it and see why that isn't right. When I go twice to the right and add a percent sign, that would then be 60%, because this empty jump would also fill in with a 0. I don't want 60%, I want 6%, which is 0.06. Twice to the right and add the percent sign does equal 6%.